I don't talk over people, so you need to lower your voices, please. We are continuing with fractional division, but we want to go back and review multiplying fractions, and then we're going to go into dividing fractions and then dividing mixed numbers. So right now we are reviewing multiplying fractions as a refresher. So let's talk about it. We know that when we multiply fractions, we multiply the numerator and then multiply the denominator. Yes? So you are multiplying the two top numbers and then the two bottom numbers. Any questions about that? What do you do after you multiply the two top numbers and two bottom numbers? See if you can simplify. What can you do before you multiply the top numbers and the bottom numbers? That's dividing. Good job. You can reduce before you multiply. So, for example, the problem they gave you on B, both of the 7s can be divided by 7, so they can just turn into 1. So when you solve it, you just have 1/8. And they showed you that and they went down. Any questions about that? Everything I write on the board, you should write on your paper. All right, so I want you to do the 4 problems that they gave you for practice, 1, 2, and 3, and then the word problem over here, and then we will go over them in about 3 minutes. Go for it. All right, guys, let's come back together. We're going to go over the word problem first. You have 9/10 of a bottle of juice. You pour 1/8 of the juice into a cup. How many or how much of the entire bottle did you pour into the cup? So what do you think I am doing? Multiplying. That's what it says at the top of the page, right? So I'm multiplying 9/10 times 1/8, and I get 9/80. Can I reduce by 2? 3, 4, 5, 7? No. So we are done. So you poured the word problem and needs word answers. 9/80 of the bottle. Any questions? All right, number 1 on the problem. 2 times 1? 9 times 3? And I'm going to divide both of those by 2. 3, 5, 7. Then we're done. Number 2, 4 times 7. 28. 5 times 10. Can I divide those by 2?
Yes.
Okay, so I divide both by 2 and I get 14 over 25. Can I divide both of those by 2? 3, 5, 7. Then that's our answer. On number 3, can we cross reduce before we start multiplying? Yes, 3 and 9 can both be divided by 3. So that makes 1 and 3. 8 times 1 is 8. And 3 times 15 is 45. So both of those be divided by 2. 3, 5, 7. Then we're done. Any questions about multiplying fractions? Say that again. So you just multiply across. So you would have gotten 24 over, and those can be divided by 3, and that equals 8 over 45. Same answer. If you add the numbers together, 5 plus 3 is, 8 plus 1 is 9. That means it can be divided by 3. Any questions? All right, let's look at the next one. Dividing fraction. So we haven't gone over the standard algorithm for division that much, so let's look at it today. When you are dividing fractions, you're multiplying by the reciprocal. And the reciprocal is basically the other fraction turned upside down. So reciprocal, if I had 3/4 times 2/5, divided by 2/5, I would multiply, keep change, and then flip my second one. That's the reciprocal. Make sense? You're just flipping the second fraction upside down. You cannot multiply across like, divide, words are hard today. You cannot divide across like you multiply. You have to keep change flip. All right, so to write the reciprocal of a number, write the number as a fraction, then invert the fraction. As they showed you, 2/5 becomes 5/2. And 7, we know we put whole numbers over 1. So the reciprocal would be 1/7. Does that make sense? All right, so divide. To divide a number by a fraction, you multiply the number by the reciprocal of the fraction. We call it keep, change, flip to help you remember that. So please write that up here. This is to help you remember what you're doing. You're keeping the first fraction the same. You're changing the sign to multiplication. And you're flipping the second fraction upside down. Make sense? And I'm actually going to make this a little more. So I'm going to say change to multiplication, just so you remember. And then flip. Any questions about that one? All right, so let's look at the example they gave us. They gave us 1/5 divided by 2/3. So they kept the first one the same. They changed the sign to multiplication, and then they flipped the second one upside down. Does everybody see that? Yeah. That's exactly what you're doing every time. So 1 times 3 is 3, and 2 times 5 is, and that is the answer you get. Any questions about that? Good. I want you to try 1, 2, and the word problem. So you have 3 problems to work on, and I'm going to give you about 3 minutes. Go for it. So what do we do for whole numbers before we can work the problem? You always put the 1 as the denominator. You make it a fraction, and all whole numbers go over 1. Then our directions for dividing fractions is what? Keep, change to multiplication, and flip the second one. So I get 1/6. Make sense? Yeah. All right. The second one did not have a whole number, so we don't have to change anything right now as far as the problem. So what do I do to divide fractions? Keep, change to multiplication, Flip, the second one. Every time. 3 times 4 is 8 times 1 is? How many times will 8 go into 4? 2. 1. With how many left over? 4, 12. Sorry, 8. Then I simplify those by 2. Yes, I am talking over a lot of people, and I do not like talking over people. Can I divide those by 2? Yes. So I end up with 1 and 1/2. Any questions? Yes. Of course you can. Yes, and I'll do more of those on the next page. I like to show over. All right, what are you doing? Oh. Okay, the word problem. A piece of wood is 5 feet long. How many pieces of 5 6-foot can you cut from the piece of wood? So what am I doing? I am dividing the 5 feet of wood into 5 6 pieces. Ask yourself when you're working these out, what are you dividing? You're not going to want to cut, if we're talking about people, you're not going to want to cut them in pieces. So you got to know what you're dividing. Got it? All right, so what do I do first? Change. Uh-huh. Left. What do I do first? Yeah. Make my 5 a fraction, my whole number. It goes over 1. Then I keep change to multiplication. Flip the second one. Yes? Here, I have 2 5s that are opposite each other. They can both be divided by 5 and they turn into 1. So then I get 6 over 1 when I multiply, which just gives me 6. But this is a word problem, so what is my sentence? You can cut 6 pieces of wood. Guys, I don't care if it's lunchtime, even if it was your lunchtime, we release you. The bell does not. Got it? Okay. All right, let's look at the next page. And yes, it is very true. Mr. Moore, do you want to do this one?
There is a slight difference when we get into the mixed numbers. Okay? So on our mixed numbers, there's really 2 major steps we need to do. I would add a 3rd step to it, but we use these 2. So again, your highlighters can be helpful. So your first step, if I have mixed numbers, I must make them improper fractions. So there is step 1. Once I have done that, then we kind of just make it an all-inclusive. Then I'm going to divide as I would with proper fractions. So in other words, now you go back to the algorithm that we were just doing, where we do our keep, hit, change, flip. So again, remember what we're doing is we're multiplying by the reciprocal, because it's really difficult to think about dividing by fractions. Dividing by pieces and stuff doesn't make sense. In order to do it mathematically, our divisor has to be a whole number. So instead, we're going to multiply by the reciprocal because it gets us the same answer. So we've got another example. So if I have 1 3/7 divided by 2/3. Our first step is we need to take our mixed number, make it an improper fraction. So you remember how we do that. So multiply 7 times 1 is 7, then 5, 3, 7, 8, 6, 10, 7. Guys, I'm going to give you a big hint. These are wonderful test questions for us. Why? Because most of you will do the slam dunk and then forget that I now need to change flip. Remember, you have 2 steps. Do the slam dunk, figure out proper fraction, but we still at this point need to do our multiply by the reciprocal. So I'm going to keep the first number, change its multiplication, flip. I'm multiplying by the reciprocal. I love the fact that we can't pull this one in because it's really all 3 and 4, so I've been trying to teach you about doing reductions. It says I have a 2 on the bottom and a 10 on the top. If I both those by 2, I make this a 1, cross that out, make it a 5. So now I just multiply. 5 times 3 is 15, 7 times 1 is 7. 7 goes into 15 twice with 1 left over. So that becomes our new range. Has everybody seen the process for multiplying my mixed numbers? Okay, it's really 3 steps. You know, we've got 2 of them up here. So as part of step 2, you may want to add this. Keep change flip. I think it's almost like Kentucky Fried Chicken, but it's a little different. So we've got 3 problems for you plus a word problem. You guys about 8 minutes trying to solve all 4 of them. Your steps are right there. Okay? Any questions? Good. 8 minutes. Go. 4 problems. If you remember the steps, this should be relatively easy, especially if you have followed advice about looking for reduction. Okay? So on our first one, step 1, we need to slam dunk. Multiply, then add. 2 times 4 is 8, plus 1 is 9. I highly recommend it. Write it down as a division problem so that you don't get confused on where you're at in the problem. Once I've done the division, now I can do my keep change flip. So I'm going to keep 9 4, change the time, flip. So that becomes 4 over 3. I now look for reduction. Another key, I cannot do reductions until it's multiplication. You can't do reductions in division. Okay? So now that I'm in multiplication, I've got a 4 on top and 4 on bottom. Those become 1. 3 on bottom, 9 on the top. I can divide both those by 3, so I get a 3 and a 1. So now after 3 times 1 is 3. 1 times 1 is 1. 3 over 1 equals 3. If you did not do reduction, you did. 9 times 4 was 36. 4 times 3 was 12. So I can divide both those by 3. Gives me, I can write them both by 12. And I see I get 3 over 1, so it equals 3. So you get to the same place, but you have more chances to make a math error. Okay, number 2 is much the same. First step, we have to slam dunk, but in this case, I have to do both numbers. So 4 times 3 is 12, plus 3 gives me 15. 12 times 2 is 24, plus 1 is 25. Now that I have made them in proper fraction, still need to do our keep change flip. So I'm going to keep the 15, change, times, flip, 12 over 25. So I, again, like reduction, so I can divide 4 and 12 by 4, gives me 1 and 3. I can divide 15 and 25 by 5, gives me a 3 and a 5. 3 times 3 is 9, 1 times 5 is 5. 5 goes into 9 once with 4 left over. Did not do reduction. Then it becomes really fun. So I got 15 times 12 is going to be 150, 180 over 100, which I can divide by 10, get me down to 18 over 10, which I can divide by 2, get me to 9 over 5, which I finally got to where I needed to be. 1 4 5. A lot more steps, right? By doing reductions, guys, all you're doing is saving yourself a lot of work. We'll really see that in our last one here. Feel free. I don't know. I'm enjoying that. Okay, guys. Again, we need this slam dunk. 6 times 9 is 54. Plus 1 gives me 55. Then 5 over 6. That one's already a practice, so I need to still be doing. But now I need to do my PK flip. So 55 over 6, keep it, change the time, flip my second number, 6 over 5. Now I can look for my reductions. I have 6 on top and bottom, those become 1. And 5 and 55, and I both those by 5. 1, 5 divided by 1 is 5. 11 times 1 gives me 11. 1 times 1 gives me 1, so that becomes 11. If you flip that to reduction, then I've got 55 times 6 gives me 30, 330. 330, and then I've got 6 times 5 is 30. So I can divide both of those by 10. Gives me 33 over 3. 33 divided by 3 equals 11. So again, you can't get there, but you're doing a lot bigger math, far more chances for a math error. If you need a couple exercise, it's going to make your life easier. Okay, our word problem. A bag contains 21 cups of popcorn. Eat 2 1/3 cups of popcorn each day. How many days does the bag of popcorn last? So, anytime you're looking at these types of problems, you can tell that I'm taking apart a little bit each day, right? So what operation is that? Division. So first thing you need to ask yourself is, what is it I'm dividing up? I'm dividing 21 bags of popcorn and 21. So I have 21 being divided each day into 2 1/3. Pretty good on that? Now, start making them in proper fraction. Whole numbers, I just put it over 1. Mixed numbers, I need to do our slam dunk. So I'm going to multiply and then add. 3 times 2 is
6.
Plus 1? 7. So that becomes 7/3. I don't like that 7, sorry. Now I need to do my key change flip. So 21 over 1 times 3 over 7. I have a reduction I can do here. Now I just have 3 times 3 is 9. So the popcorn lasts for 9 days. Remember, anytime we are doing a word problem, practice the A full sentence answer. Is there anyone that has questions on that? That is a basic expectation. I shouldn't see computers up. I don't know what's going on over here. Any questions on this page? Okay, let's go ahead. We're going back to the book. Going into page 50. We're going to talk more about modeling. And we're going to give you guys another form of model to use for modeling in practice. In the model, what we're going to do is we're going to take our dividend, the part that's being divided, and we're going to make that the top part of our model. Okay? So we're going to use the number line to help you be able to figure out where it is. And we're going to say, okay, my top box is 3/4. the divisor is going to go on the bottom. So the bottom is going to show us how the top part is being broken up. In this case, we're breaking it up into 1/4 intervals. So we're counting. We say, okay, here's 0 for both the top and the bottom. The bottom I'm going by 1/4. 1/4, 2/4, 3/4. So how many did it take for me to get from 0 to the end of the top box? 1, 2, 3. So what does that equal? Does that make sense for you? Now the question to ask yourself again goes back: how many 1/4 are there in 3/4? So when you do that, that is going to help you to understand this breakdown. So what is the quotient represented by the model? 3/4 divided by 1/4 equals what?
3.
So interpret the quotient in terms of the situation. So what we'd say is there are 3 1/4 in 3/4. That's you what you're doing. It's very distracting for everyone. What? Okay, our next one. My question to describe what each division question is asking. Guys, my question is very simple. It's saying, how many of these are there in this? So I'll give you the first question. How many 1/8 are in 1/2? That's our question. Okay? Then draw a model to determine the quotient. So we're going to do a model and then write a sentence to describe your answer. So there's really kind of 3 parts. Part 1 is this. Part 2 is your model. So when my model starts, the top is the 1/2. So I find where 1/2 is. I draw a big box on top. That's 1/2. Then I look at my divisor. I can break my number line up and say, okay, there's 1/8, 2/8, 3/8, 4/8. It's 4/8 is equal to 1/2, yes? And then I can say, okay, how many 1/8 were there? So it equals 4. Then write a sentence to describe my answer. There are 4 1/8 in 1/2. Make sense? You said no. Really, which part didn't make sense?
All of it.
So you don't know that 1/2 is halfway between 0 and 1? So it's not all of it. Said you knew that. So you can't draw a box from 0 to 1/2. Really? That represents what we're dividing. That's our dividend. So you can't cut the number line into 1/8. Because I got the end of my mouth. If it helps you, we can do the rest of them. So it'd be 5/8, 6/8, 7/8, and then 1 is 8/8. That helps you, but you don't need any of those numbers. We have to solve an extra word, but if you need it, if that helps you, do it. Okay. And then the last part, you can't count that there's 4 of them, so I get to the end of the model. Really? I'll come talk to you individually on this one, okay? All the rest of you, let's go ahead and see if you can do part B by yourself. Okay, so again, remember on the top of my model, is my dividend. What is it I'm dividing? In this case, it's 3/4. So the way I tend to do this, in order to help me break it down, I start in the half, and then I'm going to get on 14 sides. So 1/4, 2/4, so 1/2, 3/4. So here is the top of my model. That is my 3/4. Now, because I'm breaking it into 3/8, I'm going to put those on my number line as well. So now 1/8 is going to be halfway between 0 and 1/2. This would actually be 2/8, 3/8, 4/8, 5/8, 6/8. So I'm doing groups of 3/8. On the bottom of my model is going to show how many groups I do. So I'm going to go to 3/8. So I've got one group, and I add another 3, that gives me 6/8. So I needed 2 groups to get there. So my question was, how many 3/8 are in 3/4? And then my answer is, there are 2 groups of 3/8 in 3/4. Okay, are we good on this so far? We've got 5 minutes to try to finish this page. So, create a model, represent each situation, and then answer the question. Mason has 2/3 of a foot of ribbon. He needs to divide the ribbon into 1/6 foot pieces. How many pieces can he cut from the ribbon? So, because they said we need to do a model, we'll do that first. To me, an easy one, we need to write it first. I have 2/3 of the ribbon, and I'm dividing it into 1/6 pieces, yes? Okay? So my model should look something like this. I've got 0, I've got 1, I'm doing 2/3, so 1/3, 2/3. Here's my top part of the model, 2/3. I'm dividing it into 1/6 pieces, so that's going to be 1/6, 2/6, 3/6, 4/6. If I'm dividing it into pieces of 1/6, that means I'm going 1, 2, 3, 4. So you can cut 4 pieces from the ribbon. So that is your model. The other classes we're making you do that by themselves. We're almost out of time in this video. So here's the good news. We're now going to switch from the models to just doing the math. Okay? So the math on this would have been 2/3 divided by 1/6. I'm going to keep, change, flip, so that I can multiply it by the reciprocal. I have 1 reduction, I can divide by 3. 2 times 2 gives me 4. So you can see mathematically it was really easy to solve, right? If the models help you, have it help you. Use the models. But guys, if you'll remember, keep, change, flip, remember the extra step. I've got mixed numbers, must slam dunk, making the proper fractions first before you keep, change, flip. So you've got 2 more problems to do. Go ahead and do numbers 3 and 4. We'll give you guys about 2 to 3 minutes. I'm sorry, 4 and 5. Correct. I did number 3. Okay, guys, we only got 6 minutes left in class. We still got to go over homework. So I'm going to go ahead and hit this. Again, marking your text is going to help you immensely. It will help people like Simon understand what the answer is. You do all the math right. If you don't answer the question, if you done it right, No. So I've got a trail that's 4.5 miles long. Signposts divide the trail into sections that are 3/4 mile long. How many sections does Nicole like? 3. So should my answer be miles?
Yes. No. No.
Then what am I answering? Sections. Again, what am I dividing? Dividing the 4.5. How am I dividing it? Into 3/4. Step 1, slam dunk. Multiply, add gives me 9/2. Divided by 3/4. Do not forget to keep, change, flip. Keep, change, flip. We're multiplying by the reciprocal. Reductions, I can divide by 2, I can divide by 3. Gives me 6/1 or 6. So Mikhail created 6 sections. Guys, stop the chatter, please. If you have a question, raise your hand. Okay, our second one. Aster has a board that is 3 1/3 feet long. So I'll finish this on the video. Your homework is pretty straightforward. Look at the video, guys. Make sure you do it properly, okay? Okay, so I'm building it second early. I'm cutting the board into 5 12-foot pieces, and how many pieces can you cut it? Again, what we're cutting is the 3 1/3, and we're dividing it into 5 12-foot pieces. So we need to start with our slam dunk, turn it to an improper fraction. We got 3 to 9 plus 1 is 10, divided by 5/12. Now we do our keep, change, flip. 10/3 times 12/5. Next again, we've got a couple of good reductions. We can go on both ones. Second, 4 times 2 is 8, 1 times 1 is 1. So that means there are 8. So you can make 8 pieces out of the board. Okay, going to the homework. Page 59. Explain how to use a model. We went through the models quite a bit, so the easy one to use would be a number line model. Is what I would use to explain that. Talk about the top and bottom and how you divide that up. The good news is most of today's homework is straight up calculation. Calculate each portion. Remember, our process is keep, change, flip. We're multiplying by the reciprocal for all of those. Okay? There's only 3 mixed numbers. Don't forget your extra step on the mixed numbers. You must do the slam dunk in order to put them in proper fractions. The back page, the rectangular table has an area of 21 square feet. Width of the table is 3.5. What is the length? This one's easy because area is just the length times the width. So we've done the 21, we're just dividing that one by the 3.5. Second one there, we're triangular tangent on that goes is 3/4 square inches. The height of the triangle is 1/4. What is the length of the base? One issue on this, make sure you remember, there is 1/2 the base times the height for triangles. They've given you the area, they've given you the height, so you're figuring out what half of the base is. If you solve this, you're going to find the base, then you're going to need to double that, and then our formula is only half of the base. So make sure you take that into account when you make your answer. Scratch again is optional. Good luck, everybody. If you need help,